What's going on, you guys? Mr. Allen here. We're about to do some non-right triangle trig. We want to solve for all missing sides and angles in triangle ABC. But it looks like we already were given 3 sides, so we're just solving for 3 angles. First thing I'm going to do is I'm going to draw a triangle. So let's do that. I'm going to do my best to draw the most perfect of all triangles. Let's see here. Oh, that's beautiful. It's beautiful. So we've got, let's say this is A. We'll go with this being B and this guy being C. So across from A is my 14-meter side. That's my A side. Across from B is going to be my 9-meter side. And then across from C will be my 16-meter side. Got my triangle labeled. So since I have 3 sides, meaning this is a side, side, side situation, right? When we're dealing with non-right triangle trig, we often reference those side, 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 angle, side, angle, side, angle. It helps us identify what type of situation we're dealing with. I got all 3 sides, which means I would not have a completed ratio in my super proportion for law of sines. I cannot use law of sines, which is always my go-to because it's the easiest of the 2 formulas to work with. It's the least complicated. So for this one, I'm going to have to set up law of cosines, and I'm going to solve for my largest angle, angle C, first. So when I set that up, that means I'm going to do 16 squared is equal to, and it's going to be 9 squared plus 14 squared. I could have done those in either order there because it's addition. And then minus 2 times 9 times 14. So those 2 sides show up again. And then the cosine of angle C. So I'm solving for an angle here, which means I'm going to have to do some solving an equation and like bring things to the other side there, right? And very carefully do it following order of operations. A lot of people make mistakes with law of cosines when solving for an angle due to the order of operations. So first thing I'll do here is I'm going to subtract 9 squared, and I'll subtract 14 squared. I could evaluate those in my calculator, but I'm just going to type them in as is, minus 14 squared. So those cancel, and that's gone. I'm going to type that in my calculator right now, okay? No need to really like evaluate them all and deal with bigger numbers. I'll just do it right here. So 16 squared minus 9 squared, which I know is 81, right? And I can subtract 14 squared. I think it's like 196 or something like that. But who cares? Because I'm just typing it in my calculator, yo. You know what I'm saying? Know what I'm saying? All right, there we go. So we get negative 21. So I have negative 21 equals negative 2 times 9 times 14 times the cosine of angle C. How am I going to get cosine of C by itself? That's my next goal here. Well, I need to divide by all that stuff. See, the issue is some people think to add because they see that negative. Nope. I am dividing by that whole mess right there. Now, again, you can go ahead and type this into your calculator and get a negative number and just divide by that. I'm just going to keep on showing my work here. I'll show you how I like to type it into the calculator. Got to be careful, though. So now I'm going to hit divided by. I got to open up a set of parentheses if I'm going to type it in as negative 2 times 9 times 14. I got to have that open set of parentheses there. Otherwise, it's just going to divide by negative 2. Then it will multiply that number by 9. And then it'll multiply that number by 14. I'll get some really weird number that's not going to work when I try to do the inverse cosine of it. As you see, that's our next step. So I get 0.0833. Got to have those parentheses. 0.0833. Well, we'll just do 13 with the repeating sign over it. That equals cosine of C. How am I going to get my angle C then? Well, we know that we need to use inverse cosine to cancel out that cosine. And whatever I do to one side, I got to do it to the other. So I'll go ahead and type that into my calculator. So if I take my calculator, I got second cosine now. And I can arrow up, just like I do with law of sines or whatever. I'm going to arrow up. I'm going to copy that bad boy in, close my parentheses. I'm going to hit enter. And there we go. We get 85.219 degrees. Okay. C is equal to 85.219 and change. So 85.22. 85.22 degrees. Beautiful. So I've got my first angle solved for. I always keep it written down in at least 3 numbers with the dot, 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 so that I can remember what angle it is, go back into my calculator and remind myself to use those not really rounded values, right? It rounds eventually, like 8 or 9 decimal places later in the TI-84, but it's as much as you could possibly do with the tools that you have. All right, so now I got to solve for angle A or angle B. I'm just going to go top down. I'm going to go my next largest, which is angle A. And for this one, now I can use the law of sines, right? So I'm going to have sine of A, sine of angle A over its known side length of 14 equals, and then I'll have the sine of angle C since I just found that. So sine of 85.219, dot, 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 divided by, and then I've got 16 for that side. So now I'm going to cross multiply and solve. So I'll have 14 times the sine of 85.219 and change equals 16 times the sine of A And some of this stuff will become so automatic, it'll be like just going ham in your calculator, typing it all in. I'm going to show some work since you guys are just learning this for the first time. All right, there we go. Beautiful. Divide by 16. That's the mess on the left-hand side that I'm going to now type into my calculator. So let's do it. I've got 14 times, and then I've got sine of that 85 right above there. Arrow up, hit enter, copies it down, right? I got to close my parentheses if I'm going to type this all in at once. You can either hit enter, or I'm just going to go division. I know I'm going to be dividing by 16, so I'll type that in. Boom, there we go. And I hit enter, and I'm going to get my other value here. Wait, there's another step, isn't there? Right? The 0.8719, so 0.871 and change is equal to the sine of A. That's not an angle length or length or anything like that. I've got to do sine inverse, right? So sine inverse here on both sides. Sine inverse, boom, that's canceled. And now I can get what angle A is going to be by doing that in my calculator. So second sine, and then I'm going to arrow up, hit enter. I'll close my parentheses just out of, good habits, right? It's good to have good habits. Hit enter, boom, 60.686. So 60.69, 60.686 is equal to angle A. So we've got 60.69 degrees for that angle. Awesome. I got two of my angles. There's a pretty easy way, I think, to get that third one, isn't there? Yes. We're going to do 180 minus those two. So I'm going to take that one. I'll add, and I'm going to go up to that 85, that original 85 that I got with the 0.219. Hit enter. I've got 145.906. I'm going to do 180 minus that sum. Subtract. Boom. Hit enter. One more time. We get 34.09. 34.09. 34.09. Oops, not 9. 9 degrees. Answer. We get all three angles here. Woo! That's dope, man. That is absolutely awesome. Now, you might be wondering, like, hey, do we need to check for a second triangle or anything like that? No. Side, there's only one triangle that can exist. And that's why in geometry, you're allowed to prove two triangles are the same with only the three pieces of information side. But you can't do that with angle side, because there's the potential for two triangles to exist, as you're seeing a little bit more in non-right triangle trig, if you've checked some of those things out. You know what I'm saying? Law of cosines. Then we transition to law of sines here. We got all three angles. They all add up to 180 degrees. You can double check that if you'd like. But we are donezo with this problem. We followed those wonderful laws of YOLO. You know what I'm saying? You only round once. That's what I'm talking about. See you guys later.